Hey everybody, welcome back to another fun and exciting geometry class. Today we're going to keep going talking about loci and locus points. We will be on page 177 in your book and we'll be talking about intersecting loci. What does that mean? Well, it means when loci intersect. That's why they called it intersecting loci. It makes sense, right? So what does that mean actually? Well, it means when there's two loci, so something is, in other words, you have to have two sets of loci. So you have one loci, let's say it's a circle, and then another set of loci, let's say it's a line. Well, where those lines and those circles cross, where they intersect, that's what we're talking about today. So let's first of all start off with a secondary definition of the word locus. We already did the one that basically talked about how it has to satisfy a specific given criteria. Okay. The second definition is loci is a path traced by the point moving under the given restrictions. So if you restrict, here's an example, you restrict your compass. Okay, so you got your compass and you restrict your compass to, let's say, 2 inches, and you lock that in. So sometimes the compass has a little wheel in the middle of it, and you tighten it down and you lock it in. Well, that compass can't move because now it's locked in. Okay, so when you put that point down, that compass can only move under the restrictions that you gave it. You restricted it to 2 inches. So it can only move in that 2-inch restriction. You can't. Now, some compasses, right, you get the little junky ones, the little plastic ones, and they move all over the place and you can't restrict them. Isn't that frustrating? So you're trying to move it around and it's going all over the place and you've got a mess. So it's nice when you can lock it in and you can restrict it. That's what you want. You want it to be restricted. You don't want it to freely move around. You want it to lock in where you tell it to lock in, and that way you can make your circle with it the way that you need to make your circle. So that's kind of the definition number 2 is it's moving, okay, but it's moving under a restriction. What's the restriction? Well, it's the criteria that you gave. It's the given. Okay, so whatever that given is, but now this time it's moving, so it's a little bit different. Basically, the same shape is going to be drawn, but this is more the idea of the motion, the tracing of the path. This is the movement. So the locus does make movement. All right, let's look at this. I gave this example. I think the other day. So let's pretend like we're in a classroom and we're looking at the front of the classroom. So it's painted purple. I don't know why they painted their classroom purple, but they did. Okay. So let's say that we give the restriction. Let's say that this classroom has a 10-foot ceiling. Okay. So this is the floor. And this is the ceiling. Okay. Now, if I measure out, let's say my restriction that I put on this is 3 feet. Okay. So there's a locus point, and this is at 3 feet from the floor. Now, if we keep drawing these points at 3 feet, pretty soon we'll get a line. Okay. Now, here's what this is saying, though. This is saying this definition of locus, which is just a little bit different, is like saying, okay, so we start at 3 feet at the one side, and we draw our line all the way across. In other words, it's the tracing or the movement. Now, notice we still get the same result. If I was to come in here and if I was to draw points on every point of that line, I would get my line sooner or later. I would keep drawing these points until I got my line. That is the original definition, definition 1 of a locus. Definition 2 of the locus is the drawing of the line, the tracing of the points. You remember when you were little when you did connect the dots, right? So you had these little dots all over the place and you had to connect them and it made a shape or something, and you made like a horse or a dog or something like that, and then you're able to color the shape. Well, this is kind of the same idea, the tracing from point to point. That's definition 2. So we have our line here. Our line is 3 feet from the floor. And so it would be 7 feet down from the ceiling. And that's our locus point right there. Okay, that's what we were interested in. Why? Because that's what the given told us. I just made it up. It's not a real problem. It's not anything, like tangible. It's just what they said. They could have said 5 feet. They could have said 6 feet from the floor. They could have said whatever. But in this problem, I said 3 feet from the floor. So that's what we ended up with. All right, let's go back up here and let's look at this. Let's look at this problem. I'm going to give you this one first. And we'll do this together. Trace a path of locus of the locus of a point. So we're talking about the locus of a point 3 inches from the given point. All right, what does that mean? Well, let's go over to this right here. So if we have, here's our given point, right? Here's our given point, that little black point right there in the middle. So if I take and I lock my compass in, let me lock it in at, let's make it 3 inches. We were already dealing with 3 inches a minute ago. So let's lock it in at 3 inches. It's already almost there. So, all right, that's really close to 3 inches. So I'm going to lock it right there. Okay, let me get rid of the ruler. And now what we want to do, again, here's my given point. All right, so there's my given point right there in the middle. And if I take my compass and I put it on the given point and I take it and I spin my compass around, what's going to happen? Well, I'm tracing the locus. What is this locus of points that I'm tracing? Well, it's everything that is 3 inches from the center of that circle. So there we go. I've gone all the way around and I locked it in. It was restricted. It couldn't move, in other words. What did it give me? It gave me every one of these points that's on the circle. Every one of those points that's on the circle, okay, is 3 inches from the center. What does that mean? It means that we restricted the movement of the compass, and this is the result. This is what we got, okay? And so there we go. We have the same shape that we had before, okay? But now we were focused on the movement around the circle. We weren't focused on the points. We were focused on the movement, the tracing of those points. All right, the next thing that I want to do is I want to trace the path of the locus of points that are exactly 2 inches from a given line. Now we're going to be on a given line. So here's our given line. And I want to take and I want to trace all the points that are exactly 2 inches from that given line. So let me take my ruler here and let me make, it's close, but let's see. All right, so let's mark every point that is exactly 2 inches. All right, so this compass does a little bit better job of marking points than the other thing does. All right, so there's a point. We also can go down from the line, right? 2 inches down. So let's put another point here at 2 inches down. There's one at 2 inches up and one at 2 inches down. And let's come over here and draw our marks over here too so that we can see it, so that we can actually make our lines straight and parallel. I'll just move this up to 4. I won't move the ruler again. That'll save me some time. All right, so there's my points. And now what I want to do is I want to take my ruler. Well, I don't even need my ruler, to be honest, because this program allows me to do it without it. So I'm just going to go here. Let me change my color. I'll change this to a red line. So if I start here on this point and I connect these dots, notice that it's the connecting of the dots. It's the tracing. Now, I didn't measure all the way down, but if I would, that's what I would come up with. Notice my line is parallel to my original black line. And then I just do the same thing down here, and I would connect these dots, and they're all parallel, okay? And these red lines are exactly 2 inches. I traced them. They're exactly 2 inches from the original black line. Go back here. That's what it asked me to do. Trace the path of the locus of points that are exactly 2 inches from the given line. So we had our given line, okay? And then I traced 2 inches up and 2 inches down, and I traced it all the way across. Now, that's not the definition yet of this lesson. What is the definition of the lesson? Well, the lesson is called Intersecting Loci. So far, nothing has intersected that we've done. We've made a circle here, okay, that didn't intersect anything. And then we made 2 parallel lines. That also did not intersect anything. So what are we doing here? What's the point of this chapter? Well, let's go down and let's look at this last one right here. In this last one, this is where the intersection is going to happen. Find the intersection of the lines and the given circle if the center point of the circle is on the given line. So this is using this. So let's use this circle and let's use this line or this set of lines. So what we want to do is come back up here and look. Find the intersection of the lines and the circle. So how big is the circle? The circle is 3 inches. And how big is how big are the lines? The lines are 2 inches away. But then it says, notice it says, if the center point of the circle is on the given line. So where does that have to be? If we come back here, the center point, and I'll put this in a different color. I'll put this in green. Our center point has to be on that given line. Okay. There's our center point right there on the given line. It could be anywhere on the given line. Okay, but I just put it there kind of in the middle of that given line. Now let's take our ruler and let's make sure that we have our compass set at 3 inches because we know our lines were right. Our lines were at 3 inches. So let's make sure that our compass is our compass is also set at 3 inches. All right, that looks pretty good. Pretty much right at 3 inches. All right, so we'll put that away. And I'll lock that in at 3 inches. Now what I want to do is I want to trace the circle. Now look what happens right there. I crossed a line. That's an intersection. Here I come back down, and I cross the line again. There's another intersection. Now I cross the original line. And I come down and I cross these 2 lines 2 times, boom, back to my original. Let's get rid of that. Now let's look at our locus of points once we traced it on top of each other. We have 3 line intersections. Where are those line intersections? Well, we have one here. All right, so there we go. I put a little blue slash mark on all of the different intersections. So what is the answer to this problem? Well, the answer to the problem is the blue intersection marks. That would be the answer. So if you're drawing this, then you must have those intersection marks. If you're using words to describe this, you would say something like the circle crossed the original line twice, and it crossed each of the parallel lines twice. You wouldn't have to, mark exactly where. You wouldn't have to say exactly where they crossed or anything like that. Let's change our given. Let's change up our given. So now instead of 3 inches, let's do 2 inches. And let's see what this does. If we change our given to 2 inches, our circle given. Well, now when we draw our circle, look what happens. Okay, it doesn't cross the parallel lines. It crosses the original line twice. The other thing that you could say here is that the original line creates a diameter. So that's interesting, okay, because it goes right through the center point and it touches the circle. But notice that we have a crossing point down here, down there, and we have a crossing point down here, but they don't really cross, they just touch. So you could call those tangents. That would be a great way to describe this if you're using words. You could say the parallel lines made tangents to the circle because it touched the circle one time. the original line made a diameter to the circle. That would be a great way to describe this using words. And your quizzes and tests that are coming up, they're going to ask you to describe these types of things using words. So going back to the original one that was 3, and I'm not going to make it perfect. I'm just going to kind of put it on there. So going back to this one, you could say that the parallel lines made secants because they're crossing through, right? Okay, so they made secants because they're going right through the circle. So describe it using, using geometry terminology that you know. So in that one, you could say diameter and secants, and you could tell how many times it crosses and things like that. Okay. All right, well, that's all I have for you today. Hope you learned something. Hope you enjoyed the lesson. If you missed anything, make sure you slide it back and watch it again, okay? All right, we'll see you later. Bye-bye.